Hello everyone, this is KK Matics, the solution to your mathematics. Today we'll be dealing with bearing the vectors part 4. So today, what we're dealing with today is using distance bearing formula to solve three-figure bearing. So let's consider an example here. Example 1 here. Here we know that two cyclists left a point P. I think we've already done this. Yeah, in the earlier example that we did in the previous video, if you not watch it, then I suggest you watch it. In the previous video, we talked about this. We solved this using the what? The sketching method. But in here, we want to use the distance varying format to solve this question. Now here, we're told that two cyclists left a point P at the same time. And the first cyclist covered 300 meters on the bearing of 296 degrees. And the second cyclist covered 250 meters on the bearing of 206 degrees. We're told to calculate correct to three significant figures. A, the distance between the two cyclists, and B, the bearing of the second cyclist from the first. So the first thing we do is, here, we consider the first cyclist to be what? Now this is how it's done, using the distance bearing format. 300 meters is 2, and then that is for the distance, and then the bearing, we have 296. Now, we have to convert this to vector, and in converting this to vector, we have our what? Distance sine the degree, or yes, the degree here, which is 296, and then 300 cos 296, and that gives us these values as you see on your screen. And then we have our second cyclist. Here, second cyclist is 250 meters on the bearing of 206 degrees. And so we do the same for that, which is 250 meters for the distance, and then the degree to be 206. So we have 250 multiplied to sine 206, and that gives us minus 109.593. We do the same for 250 multiplied to cos 206, and that gives us minus 224.699. Now, here, our intention here, according to the question, we're told to find the distance between two cyclists. For us to find that, there's a need for us to name them. So let A be the point of the first cyclist covered, and let B be the point of the second cyclist covered. So we have PA. Now the reason why we have PA is because what? That's the origin. They all left at a point P. So that was the origin that they left from. So PA, which is what? This value. Remember, it's a two cyclists left a point. They left a point at the same time. So when they left the point, the first cyclist left from P and arrived at a particular point. And that point, let's say that point is what we call A. Okay, the same applies to the B. So we have PA, which is this, okay, which we found, which is this one, and then we have PB, vector PB, which is this one. So the next thing we do is to add them. So as we have there, we didn't go on ahead. We know that AP, vector AP, is the same as well, minus BA. Always keep in mind, okay, when dealing with things like this, AB, okay, vector AB, which is the distance between the first cyclist and the second cyclist. Remember, A is the point of the first cyclist, and B is the point covered by the second cyclist. And that's equal to what? A, vector AP plus vector PB. Now, always keep in mind that uh, in writing this, especially using the law of vector triangle, it's always important that you have a common letter in between the two. So that's the P and P. So that's you start with A and you end with B. And then in between them should be what? A common letter, which is P and P. Okay, that's what we have there. And so already we did say that what? Our AP is the same as what? Minus PA. Okay, so we just negate the earlier value that we had, and in negating, that's what we have here, plus this. Now this is PB, okay, that is that, as you see pointed at, that is exactly what we have there. And so we solve it in vector form, and we have our value to be that. Now the next thing we do, remember, we are told to find the distance between the first cyclist and the second cyclist. So what we do is that we're going to use the vector formula of distance, and that's what the absolute of the vector AB, which is equal to that. And so we just substitute it, we square this one and square that one and sum them. Okay, that's exactly what we've done here. And so after doing that, the next thing we do is to punch it on our calculator, and we have our value to be 391 meters approximately. Remember, we were told to approximate it in three significant figures, and that's what we've done there. Yes, and so the next thing we also have to consider here is considering the angle or the bearing, okay, the bearing. And so with what we have there, the next thing we have to do is for us to find what we know that the bearing is what clockwise. Now remember, we're given the bearing of uh, now it's important for you to realize here that the bearing that we were given here, our interest here is to make use of theta. Okay, so a little bit of sketching is very important here. You still need to do some little bit of sketching here because tan theta, so that we can use this information, okay, to find our theta, and that's what theta inverse be equal to what. So we get our theta to be, now what's your theta? Tan theta equals 356.21 divided by 160.045. Yep, and that. So this is the angle. Now watch here. So with this, we have our angle here, and this is the x value. Now, don't be confused here. The ones you see that you see here, that is the x value, okay? That x value is the same as the value that we have here, which is 160.045. And then the y value is minus 356.21, and that's what you have here. And so all you have to do is to what? Ensure that what? Your line, if you draw a line, okay? Now watch it. Don't be confused here. Now the x value is positive. That's the reason why we have 160 and the what as a side. And then the y-axis here is y value here is minus, it's negative. So negative will lie below the x-axis, and that's what we have here. So that's the reason why we have this shown in this format, indicating that what we have to draw a line in between and find the angle here. You don't find the angle here, you find the angle here and there, okay? That's the reason why we have theta there, because it's important. Because if you find the angle here, that's equivalent of you getting 180 degrees, which is unnecessary, okay? This is the main bearing that we need, okay? And remember, this is three-figure bearing, so it's important for you to have in mind that it's what it's clockwise, and that's we accumulated. That means that we measure it from what the north up to the line, the slanted line there. Okay, so that's exactly what we do. So here we know in doing that and doing so, we know this theta is opposite to this. Okay, if we draw a line here, okay, if we were to draw a line there like this, draw a line like this, to join that, and then another line to join this, okay, as you see on your screen, you realize that this distance here, okay, this is a distance is never negative, so keeping that in mind, okay. So this is a distance, and the distance is positive 356.21. The negative there is actually telling us the position where that value will lie. So that's what that you should keep in mind. Okay, so here we have that. So and the 160. So this here, okay, just keep in mind this is the x value. Okay, this is the same as the x value. So if this is 160 degrees, sorry, 160, then keep in mind that this is also what 160. Okay, because opposite sides are equal. Okay, and this side that you see here, which is the y-axis, this side is equal to that side. Okay, is equal to this side, and so you realize that the theta is facing what? This line there. Okay, it's facing this line there, and this line is what? That's what 356. Okay, right, and this is a bit of a problem here. So 356.21. So it's the same as the length here. Okay, that's the distance. Okay, keep in mind, and the 160 is the same as here. Okay. Keep in mind that what you have here, okay, from here to here is 160. We're talking about distance here, okay? You are interested in the distance. So here, the length you have here, the 356 here, is the same as the one there, or the opposite. Okay, this is also 356. Keep in mind, just like that of a rectangle. Okay. Okay, so with this, we know theta here is facing this guy, so that's opposite of that. So if you're using tan, which is the trig ratio, toi means opposite of what? Adjacent here. So our opposite here is 356.21, and our adjacent here is 160. So that's the reason why we have this there, as you can see on your screen. And then we make theta the subject, find the tan inverse, punch this on your calculator, and we end up with our theta being 65.8056. Now, after finding that, keep in mind that in finding what bearing, it's important that according to the rule of three-figure bearing, it's always important that you measure it clockwise from the north to where it falls. So from here, we measure the degree from there to this line. And since we know the first quadrant is 90 degrees, we also know the theta here is 65.8056. We can then go ahead and add, we can add 90, okay, to the theta here. So by so doing, and adding them, we end up our value to be what? 156 degrees in three significant figures. Example 2. Now, in this example, we want to talk. Now, example 2. We have the question here that an aeroplane flew from town A, travels 200 kilometers at a bearing of 135 degrees to a town B. It then travels 250 kilometers from town B at a bearing of 045 degrees to town C. Here we're told to find the distance of A from C and B the bearing of A from C. Solution. Now, here, in using the distance bearing format, here we have our distance here, which is 200, and our bearing, which is 135. So that's what we written here. Remember, according to the question, we told that an airplane flew from town A and travels to town B. So that's from A to B. So that's AB. So we regard this as what? Vector AB. And so for this distance and bearing that we have here, we'll have to convert it into vector. And in considering the next statement, we were told that it then travels 250 kilometers from town B at a bearing of 045 degrees to town C. So from B to C. So that's going to be bearing, that's going to be vector BC. So we note that. So that's the distance and that's the bearing. So we're going to convert all these things, all these distance and bearing into vectors. So in converting, we have 200 multiplied to sine 135, and 200 multiplied to cos 135, and that's what we get. We get the values here. So these are vectors of what? A and B, AB. And then we also consider BC, vector BC. So that's 250 multiplied to sine 45 degrees, and 250 multiplied to cos 45 degrees. So 250 multiplied to sine 45 degrees is the x value, and the next one, the other one, is the y value, as you see there. So from there, watch here. It's important for us to consider the question. Now here, in this question, we're told to find the distance of A from C. So distance of A from C. So starting from C, okay, so that's CA, okay? And so we know CA, remember, we said that anytime we're dealing with triangle, the lower triangle or vectors, it's important for you to consider what? When given a vector, like for instance, CA, you start with C and you end with A, okay? It's very important you start with C and you end with A. And in between should be a common letter between the vectors, as you see there. And here, if we, after quoting this or after writing this,
when we look at what we have here with all the information or data we have here, CB here, we don't have CB here, rather we have BC. So, but we do know that CB is the negation of vector BC. And so we can use that to replace the CB here. And then we also know that we weren't given BA, but we have AB, vector AB, and we know that vector AB is a negation of the vector BA. And so we can use them to replace these ones here. So we do that, and in doing that, okay, so as you can see, vector CB, which is the negation of BC, and so you can see that both of them has been negated here. The same applies to vector BA. The vector BA is the negation of vector AB, as you see there. So if we negate it, we end up having the Y value being positive and the X value being negative, being positive, and then X value being negative, sorry. Yeah, so X value being negative, Y value being positive, as you can see on your screen. And so we go on ahead and then we just punch this on our calculator, we get this, and we do the same for the Y, we get this one. And then after that, the next thing we do is we'll have to find the absolute or the magnitude of the vector CA. The magnitude is the same as what the distance. Okay, it's the same as the distance. So the distance of A from C, we have to quote the formula, which is the square root of x squared plus y squared. And so from quoting that, the next thing we do is we just substitute the x value and we square the x value and square the y value. And that's what you see on your screen there. After that, punch it on your calculator and it gives you an answer. And our answer is 320 kilometers approximately. However, it's important to use this. Depending on the question here, the question never stated for us to leave our answer in three significant figures. It never stated that. So we can leave our answer in this form. Okay, now from there, we were also told to find the bearing of A from C. It's important. Now, for us to do so, we're going to consider these values here, the vector form of CA. So we're going to scratch this. Okay, so this is a negation. You see that the x value here is negated, so it's going to be on the what? Below the. So it's going to be at the other side. And then we also notice that the y value here is also negated, so it's going to be below. So we draw that. So as you can see, this is the x value, which is minus 318.1981. And this is the y value, which is minus 35.3553. Now, this, however, one thing you need to consider here is that you need to regard them as a distance here, okay? The negation here, it just signifies or tells us the position they lie. And so as it has done its job by telling us the position it lies, the next thing we need to consider is see it as a distance. Okay, so the 35.3553 that you see here, see it as a distance that's extending from this side, from the zero origin to this side. And we know that this is more like that of a triangle, a rectangle, sorry. It's more like a rectangle. So that means that this length here, which is 35.3553, is the same as the length here. And the same applies to this one, this side too, which is 318.1981. And this side is the same as that side. And so with that being the case, we can then use what? The trig ratio to find our theta. Now, it's important for us to regard or consider this. Now, this theta is not actually the main thing we want to find here. Now, the main thing we want to find here is this. This is what we intend to find. Okay, so we start from the from the north, okay, up to this side. So our interest here is finding here and not there, okay? Okay, so in finding that, we're going to use trig ratio here. Now we know that this is facing this part, right? And remember, this part is the more like the x-axis, which is the same as the length here, which is the 318.1981. So this is the same as that. So it's opposite facing that. That's the opposite of that. And we also know that is also adjacent to this. It's also adjacent to the 35.3553. suggesting to this, which is also the same as that. Okay, so what we're going to do is we're going to use the trig ratio, which is the so-called TOA. We do know the TOA, which is tan equals tan theta be equal to opposite of our adjacent. So we do that, and what do we get here? So we do that. You see, so this line that you see there indicates that what? That is going to be our bearing. And always keep that in mind. If we are able to find this theta, then we can find the rest of them, because we do know this is 90, right? And that's also 90, making it 180. So we already know we know the angle for the first quadrant, and we also know the angle for the second quadrant. And so all you have to do is just add them, and then what? We also add it to this theta that we have here. So we do the same, okay? And so by so doing, okay, we're going ahead, and we know tan theta equals the opposite. So which is the opposite? That is what? The opposite of that is this. Okay, the reason why this is written in this form, sorry, this is a mistake here. The opposite, rather, tan theta equals opposite, which is what? 318. 318.1981. Okay, all divided by the adjacent. Here, our adjacent here is 35. Point 35.3553. And so we punch it on our calculator, and that gives us. And so in punching this on our calculator, I will end up with so this is going to give us okay. So the other way that we use in finding this is okay. So we're going to consider that. So we're going to wipe this. Okay. Now what we have here is we use the other way to find that. What we mean here is that in order for us to find this, okay, we decided to omit this. We decided to use this theta here. Okay, we decided to use this theta. And using this theta that we have here, okay, this theta that we have here, we know that this theta here is facing this, is opposite to the y-axis, okay, which is the 35.3553, and it's adjacent to the 318.1981. And so we use this theta here, and using tan, we end up getting this, and the tan inverse of that gives us the 6.34. Now by so doing, in getting that, okay, we know that from this is the third quadrant, and the whole of the third from the first quadrant to the third quadrant is 270 degrees. And so if we know this part of it to be 6.34 degrees, then we can subtract the 6.34 degrees from the 270. Remember, this is 90 degrees, okay? And this is what 90 degrees, okay? So that means that if I add this 90, this not to this 90, I end up with 180. But I don't know this value, the value here. Okay, so for me to find the value here I decided to find this value. And that's what? That's 6.34. And I know the value from here all up to here. And that's what? That's 270 degrees. So all I had to do is to subtract the 6.34 from the 270 to get this value. Okay, it's more like take this cake out of it and then you'll be left with this. Or take this pizza, this part of the pizza out and you'll be left with this. Okay, and so that's exactly what we've done there. This is the end of the class. Thank you for your attention. Thank you. Please subscribe and like and share. Thank you. Bye.